All right. Good morning, hello, or good afternoon, depending on when you're watching this. This is our lesson today. We're talking about 1.4, writing equations and inequalities. Previously we wrote expressions from words. Now we're going to write equations and inequalities from words. So you can see our learning targets here today are that you will translate a verbal sentence into an equations or inequalities. And it's twofold actually, because we're also going to check to see if a number is a solution to an equation or an equality. These are the two things that we need to learn today as we progress ourselves through chapter 1. So let's just jump right in. There's some words that we need to define here. So you need to add these to your vocabulary list. You should probably pause the video right now and open up your vocabulary Google Doc, right? And just put them on the side. An equation is a mathematical sentence that is formed by placing the equal sign between two expressions. So for example, if you have like 3x plus 2 equals 6, right? That's an equation. The equal sign is what makes it an equation. This over here is an expression, and this over here is an expression, but by setting them equal to each other, we've created an equation. Okay? And equation, right? Notice how that they start with the same words, right? Equation, equal. They start out with the same 4 letters, right? It means the same kind of thing. We are making an equivalent form of two expressions. An inequality is a mathematical sentence formed by placing these symbols. That is your greater than, less than, greater than or equal to, or less than or equal to, between two expressions. So it's very similar as to what we had before, but instead of saying that the two things are equal to each other, we're saying that this side is bigger than this side because the alligator always eats the bigger number, right? Rawr, it eats the bigger number. That's like, that's your first grade moment right there. They're saying that this side is bigger, not equal. So that we call them an inequality, as in not equal. So, the symbols that you guys need to kind of know, you should already kind of know these things, but let's just make sure we get them all down, right? There's the equal sign. We have greater than. By the way, these ones should be read left to right. Greater than. The greater than is on the left-hand side. That's why it's greater than. Then we have less than. And then we have less than or equal to, which is pretty much the same thing as the less than, but it also means that something can be the same to make a true statement, right? With this, 5 is less than 6 is a true statement, right? That's a good statement, very true. But 6 is less than 6 is a false statement, okay? Whereas this one down here, 5 is less than 6 is a true statement, but 6 is that should be equal to. 6 is less than equal to 6 is also a true statement. So that's the only difference between them. But like I said, you should know that because that's an old thing. This one's greater than or equal to. Again, you read it left to right. The one that you might not know, and we don't actually use that often, but it's there. This one means does not equal. So, 5 does not equal 6. That is a true statement because 5 and 6 are not the same number. I've tried. I've studied it. I wrote a thesis. It didn't work. So, writing equations. We're going to retake that verbal translation and just write it into something here. The big difference between the expressions and equations, again, is that equal sign, right? Equations means that there is some kind of equal sign in the middle. The important thing to note here is when you read that word is, that's kind of like saying it's your equal sign. So the difference of twice a number k and 8 is 12. The difference of twice a number k and 8 is 12. This thing right here, that equal sign, translated into words, means is, right? This is this. Is means like they're the same thing. And so that equal sign means is. The product of 6 and a number n is at least 24. The product of 6 and a number n is at least 24. That is going to be one of our inequality symbols. Notice that it doesn't say at least or equal to 24. It says it's at least 24. So we have to decide what symbol does at least mean. Right? At least means it's at the smallest it can be is 24, which means that it could be anything bigger than 24, right? The smallest it can possibly be is 24. So 6n has to be bigger than 24, because the smallest it can be is 24. A number y is no less than 5 and, ooh, there's a new word, and no more than 13. So notice that we've got two statements here. We have no less than 5 and no more than 13, and an and statement connecting it in the middle, which means that y, we've got two things that we have to look at when we're looking at y. It has to be no less than 5, so it can't be smaller than 5, but it can't be bigger than 13. So there's two statements connecting with and in the middle. We call this a compound inequality. That's an O. Compound inequality. Meaning that there's two, right? Just like a compound word. We're combining two inequalities. If it's no less than 5, it means that 5 is the smallest number it can be. So this is no less than 5 because y can't be smaller than 5. No more than 13 means it can't be more than 13. So it has to be smaller than 13. But notice that we had to connect them with two statements. Y, there's a statement there, 5 is smaller than, or that y is greater than 5. And there's a statement there that y is less than 13, less than or equal to 13. It's a compound inequality. And notice that in the sentence, we saw that because there's this statement, and this statement. If you see and or, you know there's going to be something that's compound. Moving on to the last thing. When you substitute a number for a variable in an open sentence like x plus 2 equals 5 or 2y is greater than 6, the resulting statement is either true or false, right? True or false statements based on the numbers. So if the statement is true, that number is a solution of the equation or inequality. Now, solution doesn't necessarily just mean answer. It's a number that makes a true statement. Notice in this problem, this one up here, there's only one number that makes a true statement. Think about that for a second. What number does that make as a true statement? Don't yell it out because then you're interrupting people. But all right here, it's 3. But think about this one. There's lots of numbers that we can put in here to make this a true statement, because anything that makes this bigger than 6 works. And so 4 works. That makes it 8. And so does 5 and 6 and 7. In fact, anything bigger than 4 is going to work, because 4.5 works, and 4.8 works, and 4.9 works. We can make that list indefinitely. So inequalities have lots of values that make true statements. So let's put this together here. Plug the value 3 into this should say like into the equation or something, right? Into the equation. and check if it is a solution. So what we're going to do is plug in 3, see if it makes a true statement. 8 minus 2 times 3 equals 2. Well, that's 8 minus 6 equals 2, and that's 2 equals 2. Is that a true statement? Yes. So 3 is a solution. How about the next one? 4 times 3 minus 5 equals 6. That's 12 minus 5 equals 6, which is 7 equals 6. Is that a true statement? No. 3 is not a solution because it's not a true statement. What about this one? I like changing colors. It's fun. 2 times 3 plus 5 is greater than 12. Notice the difference, right? There's the greater than sign. This is 6 plus 5 is greater than 12. This is 11 is greater than 12. Is 11 greater than 12? No, it is not. So 3 is not a solution. Notice I'm not asking you guys to actually find the solutions here. We'll do that on another day. What I'm asking you to do here is to just check to see if this thing is a solution. You plug it in. If it makes a true statement, it's a solution. If it doesn't, it's not a solution. 5 plus 3 times 3, oops, that plus got weird, is less than 20. Well, that's 5. I'm at the bottom of the board, so things are writing weird. 5 plus 9. I'm also right in front of the microphone, so I probably just got super loud. 5 plus 9 is less than 12. 14 is less than 20. Did I say 12? I meant to say 20. So is that a true statement? Is 14 less than 20? No. No. So 3 is not a solution. Not a solution. That's all I need you to do today. Let me know if you got questions, and you can start your assignments as soon as I can get out of it.